All right, good to go. So all the folks that showed up here, what is Docker? And I'm not talking about these pair of pants, but like, what is Docker from your perspective? Yeah, go ahead. It's a container, all right? Okay. Okay, all right, yeah, who else? Okay. A thin virtual machine. Okay. When I first saw the word Docker, and then I understood what was running it, you know, the Linux container systems, I was like, this is just like Linux jail, right? Like basically you just have an area of the operating system and that's what you do in your little area. And all your dependencies are there. And there's some dependencies that you don't need to run on your own. Now, I'm the type of guy that waits on two presentations before I jump on a ship. You know, no pun intended in the Docker world, the whole logo is a ship, but like two personal recommendations. The one was I was giving a talk on DevOps, continuous integration, continuous delivery. You know, how do you deal with product solutions and service solutions? Meaning core product that doesn't change, service implementation that change. How do you make that magical? And this guy came up and was like, so do you use Docker? And I was like, no, what's that? So he walked me through the process of how container technology in general works. And I was like, okay, I'll think about it. And then I saw a presentation at Google where the program manager for Kubernetes was talking about Kubernetes at Google. And he was like, oh yeah, all of Google runs on containers. And I was like, okay, I would be pretty much an idiot if I didn't learn this technology. And then when I got into it, this is like 2.5 years ago. So right when I got into it, one of our clients said, oh, we do everything on Docker. So that third one kind of sealed the deal. I just realized that if these software as a service companies were starting to adopt container technology now, kind of the early adopters, and the reason why, because you'll see, save money, save time, you know, iterate quickly, basically be more efficient. It's more of a cultural shift that will stop a company from adopting Docker rather than a technical shift. So I'll tell you, let me see if this thing works here. Is it working? Is it working? Okay, no, that was a slight delay on my clicks because I think I'm recording. Here we go. So just a quick agenda for today. I'll tell you a little bit about myself so that you'll believe what I'm talking about, give a little bit of credibility about the words. We'll talk a little bit about why do we distribute everything, or why is that something that's potentially useful. And we're going to cover 4 top categories of technology. So computing, messaging, data persistence, and basically infrastructure. And the representations are basically Spark, Kafka, Cassandra, and Docker. So before we get into those things, who could tell me what Spark is? And not like the Transformers all Spark, but like, what is Spark? Streaming is one aspect of Spark, sure. Yeah, go ahead. Memory processing. Okay. Distributed computing. I mean, the answers are right there. Okay, I'll take that. Distributed computing in memory with some streaming. Okay. What about Cassandra? Anybody heard of Cassandra? What does that do? It's a columnar database. Okay. Anything else? Eventually consistent. Okay. High availability. Go ahead. Sorry. Anyone else? Column families. Although now they call it tables. And what about Kafka? Streaming. Okay. Distributed logs. Okay. Log processing. Okay. And then Docker we already covered. So this just helps me get an understanding of what the audience is. So I know this is an architecture roundtable, so I'm not going to constrain myself. It'll be jargon. So if there's anything that you don't understand, just raise your hand. All right. And then we can also, you know, obviously have questions afterwards. All right. So who am I? You know, I was 16. I built a hosting company. I built machines, physically towers, mid-towers. Had about 30 boxes in my house, had to get a new circuit. Initially it was a T1, and then when the bandwidth started to run out, we had to go, I designed a data center. So I understand infrastructure pretty well. So I thoroughly appreciate what Docker and virtual machines give us, because instead of waiting, half a day to build a legitimate computer, you could basically, create a whole army of servers and containers now with a few lines of code. Web application development, hosting. So I left the business of hosting because it sucks having to answer the phone call at 3 a.m. in the morning because somebody's server is going down. So I was like, I'm going to be out of this business. And I went into application development, making applications. And because I'd been dealing with hosting, I was exposed to so many different types of computing, Cold Fusion, JSP, PHP, Perl, whatever. But eventually, those clients were like, can you just deal with the servers? And so somehow I found myself back into hosting and essentially doing what people do today. They call it software as a service. I was the managed service provider for a application service provider. So that worked out. I got a lot of exposure to carrier neutral facilities where I saw Google and Amazon and eBay and what their data centers looked like. And I was like, I never want to get into the business of servers and hosting ever again. So I got out of that business and actually left entrepreneurship for 3-4 years. Got burnt out from really piddly small customers. And I worked for some large firms. And I think that's where I started to see that it's actually the same thing everywhere. Business is business. And people want technology to make their lives easier, make their jobs easier. It doesn't really matter if you're in a big company or a small company. Ultimately, technology is a tool. It's not an end in itself, but it's a tool. And now, for the last 7 years or so, our firm is focused in helping internet teams or internet software teams as a management consulting firm. And then always, because we're dealing with internet teams and internet software teams, we're dealing with data. A ton of data engineering. I don't want to call it big data. I don't want to call it data science. I would say data engineering is one, data architecture would be another way of thinking about it. But, when we deal with data, you end up making data products. Then you need to expose data products as APIs. And then when people want to scale that up, how do we do that? So that's why I know what I'm talking about, because I've kind of been around the block. And I always say that to folks, because I don't want you to just take what I'm saying at face value, right? There's a reason why I'm here, and it's to propagate some ideas, but it's because of my own experience. It's not because I'm selling you anything. Because if I was sold this stuff the same way I'm selling you, I would probably have saved, 100 or 200K of labor off a few projects, because this stuff just makes life easier. All right. So this is what I do with our clients. Our team generally helps people get their shit together. We move data through different processes. And as you can see, there are some icons that have Docker on there, because that just helps me do my job. I deal with business information. And as in, I don't work on consumer applications unless the consumer application is part of a larger infrastructure. But essentially, business information is what I focus on. And different types of business information requires different types of technologies. Most businesses go through these phases. I didn't come up with this approach. This comes from a book called Enterprise Architecture and Business Strategy. Every business starts out with business silos. And actually today it's even worse, because you just subscribe to Salesforce and you subscribe to Basecamp and Dropbox, and all of a sudden, you have these data silos that you're dealing with. And that's the challenge that our clients have. It's data in different software as a service systems, and they need to streamline it. The cool thing is that today, the standardized platform phase doesn't have to be Linux or Java. The platform is the internet. Like Larry Ellison was very prophetic when he says the network is the computer. Today, that is the truth. REST APIs, microservices. Okay, and Docker actually helps people get to a unified platform without having to buy into one technology or another. Right? That's the beauty of what Docker can do for a company that's going from having a ton of business silos and having to get to being more streamlined. And eventually they can create data warehouses and have an optimized flow of data. from one thing to another, unless they buy. Yeah, go ahead. Enterprise Architecture as Business Strategy. It's a Harvard Business Press book. It's got really amazing case studies about firms and how different types of organizations basically deal with structure and processes in their organization and where technology plays. All right. And then, the goal is that as you grow in technology, you become more and more modular as a business, right? So when a company buys another company, they can just connect that company into their infrastructure, right? That's the goal of business modularity, right? If you don't have an optimized core, you can't be modular in business. If you don't have a standardized platform, you can't have an optimized core. And in the future, which people are starting to touch on, so in that book, they call it phase 5, which is business to business modularity. Companies coming together, doing amazing things, then disbanding. But the time that they're together, it's like a big company, right? And people are starting to be able to do that today. The idea that small firms can come together, like a movie production company, create amazing software, disband, and then the production company kind of does the managing of the application. A lot of applications are already built like that. That's why the industry of digital agency, such a nebulous term. What do you guys do? We do everything. The truth is they do everything through proxy. They have a lot of different companies that they're working with. But I mean, I have my whole conversation about whether or not they're efficient. But business to business modularity allows very globally disparate organizations to work together as a whole. So this is what I would say is a path that most companies should go through, and it's up to debate whether or not they should or not from other people's opinions. The book will at least explain why it's a must, because if folks don't get to this, if companies don't get to business modularity, every IT project will fail. Wait, that happens all the time. Every project will be over budget. Wait, that happens all the time also. That's not true. Not all IT projects fail and not all IT projects are over budget. But the goal is to create infrastructures that allow growth and are not painful to maintain. Anyone here maintain production applications? Yeah, okay. What's a production application? Like, what does it mean to have a production application?
Anything that's customer facing.
Customer facing?
Yeah, people paying.
People paying you to kind of keep it up and running, right? It makes money. Yeah. Runs the business. Okay. Anything else? So if there's a production application and 25% of your time is to keep it running, if you could take that and make it into 5%, and you're laughing because it's probably more than that. It's happened. If it could be 5% of the time to maintain a production application, then that 20% could go into research and development and innovation, right? So the promise of good infrastructure architecture is more efficient teams. So anyways, this is the problem that I solve. It's connected to clouds, take data into one place. I'm not going to go into too much of this, but most businesses are trying to do 3 things, in my experience. They're trying to find information, they're trying to analyze, and they're trying to act on it. Like, information technology is a tool so that people can do these 3 things. I don't have the empirical evidence to back this up, but do have about 20 years of experience of this is the kind of stuff that I help solve. People want to find information, they want to look at it, they want to maybe visualize it. After they visualize something, they make a business decision, and then they create some sort of process so that if this happens, do this. Okay? And you give me a business application today, and I'll categorize it into one of these areas. All right, that's a stump roll segment later on in the evening. Anyways, we're talking about scaling applications, and scaling applications today is about distributing applications. So there are some pros and cons, right? So when we distribute systems, the pro is that you can scale it quicker. You can add more units and not have to focus so much on provisioning, because provisioning is part of the architecture. But it does add complexity. And let's say Cassandra, data is distributed. And if you have multiple nodes with data replicated on it, there's a parity issue. Luckily in Cassandra, if you do a good design, you can get it down to milliseconds in terms of consistency. How long does it take for data to go from one part of the world to another? And there's always some latency issue when you have distributed. And if you have one single threaded machine, like let's say Redis, right? It's a C++ compiled program, right? You can ask it the question, it'll give it to you right then and there. Latency is very low. But when you have a cluster of Redis nodes, then you have to think about, okay, am I load balancing? Am I saving? And if I'm saving, how do I know where to look for? So there are some pros and cons about distributing, but that's the reality of the world today. Any major system you use today out there on the web is distributed across multiple regions, multiple data centers, multiple servers, okay? Actually, last time I gave a talk on source technologies, Comcast actually has a huge Apache solar server for their index that powers your TV guide search. I asked them why, and they're like, speed. That's it. And they cache the results because most people are kind of searching for the same thing. So there are times where you can have a huge machine to deal with speed, okay? If you're serving millions of people and you want to give them that SLA of less than a second for every query, that's when you do single thread stuff. So I think everybody's heard somebody at least once say, I'm gonna host my own project management system. Who hosts their own project management system today? No one, okay? I'm gonna host my own chat server, okay? You guys have a Mattermost server in your company? You probably use Slack or HipChat, right? Skype. I'm gonna make my own backend framework. Right? That was the thing you'd hear all the time, right? I'm gonna make my own front-end framework, and people still do that. How many different JavaScript frameworks are there today? I mean, too many, right? Or I'm gonna make my own e-commerce system and host it. I mean, these are things out of 1990s, right? The thought of like wanting to make your own thing and host it. And so there was this movement from hosting in your own stuff to going into software as a service. And now there's actually pretty decent open source solutions that, yeah, you could say, you know what? I don't want to do Jira on the cloud. I want to do Jira in-house. And you may have a good reason for it. But when you're a small team or even a small team in a big company and you want to be agile, hosting something yourself is a pain in the neck. Like a total pain in the neck. I don't know why people want to do it. And I hosted like hundreds of servers. Like it sucks. So I call that systems immaturity. The equivalent of software immaturity is, 20 years ago, which actually isn't a long time, but in my computer science classes, somebody would be like, I'm going to make my own operating system. And I would, as a young person, be like, wow, that's a great idea. Let's make an operating system. Who wants to make an operating system? God, there's still two people in the back that want to do it. Yeah. It's tough. It really is. So making your own stuff, hosting your own stuff is just hard. And I just say it's immaturity unless you have a good reason for it. And people do. Government needs security and privacy of information. But now with Gov Cloud on Amazon and equivalents and other cloud companies, you can kind of do that and have the best of both worlds. This idea of I can host everything, I can do everything. I mean, it's just I would make fun of this up until 2 years ago. Okay, I was making fun of the folks that wanted to host their own stuff because there's just a pain in the neck until today. Until about 2 years ago when I got exposed to Docker, realizing that it's actually easier to make software and run it on the cloud using something like Docker than to pay somebody else to host it and then manage your application lifecycle for your updates for your own software. Okay. We'll talk about Docker in a second. So Kafka came out as a technology from LinkedIn. Okay, and there's a company now that commercially supports it. They're called Confluent. And Kafka was created to solve this problem, which is getting their stuff together and putting it into one big place to do analysis, data science. That's why they needed to have one big queue that everything that was happening, I add you as a connection, I post something, you know, I import my address book, all those little events, they wanted the rest of LinkedIn to be able to subscribe to those events and do something with that information. And what they came up with is not elegant, in my opinion. I would build, actually, I forked a project with a queue based on Cassandra, but I would build a queue that has some sort of persistence layer. The persistence layer of Kafka is like the file system, the Zookeeper file system. Yeah, go ahead. Good enough. It works. Synchronizes the data, and you know what? I've seen this work in the real world at an organization that everybody with a mailing address is impacted by. All right? Everybody with a mailing address is impacted by this organization. They use this and they move 15 to 20 terabytes a day. Okay? Like a billion, I would say 1.5 to 2 million operations a minute. You can scale it. And this particular tool, I've seen that volume at only 3 or 4 virtual machines. Can you imagine moving 15 terabytes a day on 4 machines, right? So here's a technology that you may want to use, but you want to develop with it. Well, to put up Kafka, you need to have a Zookeeper ensemble, and then you need to have your own Kafka brokers, right? And you need to do all this stuff. You need to do all this stuff to get Kafka working. And, you know, I'm a lazy guy. I want to play with the technology. I don't want to have to bring up 4, 5, 8 machines to get it to work. So here's a candidate technology that could change your whole business. But the ramp to learn this and play with it is so high, people will never play with it. They go use RabbitMQ that crashes all the time. Okay, maybe it's just the team that maintains this cluster. Okay, but RabbitMQ crashes all the time. But Kafka just continues to work. Okay, workhorse technology. So here's a technology. Just keep it in your mind of something that could be useful to your business, but it's too hard to play with. But maybe another technology will help you. Okay. Any questions about Kafka? It's not an event processing platform. It can be used for event processing. It is a distributed commit log, which can be used as a queue. So you send data to it, it distributes the change, and then when you subscribe to it, you can subscribe to it either as a pub subsystem or as a pure queue. Okay. It just depends on how you configure the channel. I will not talk to you about any commercial technology on this talk. It's open source. The commercial company called Confluent supports it and offers kind of a managed version of it, but this is an Apache project. It's called Apache Kafka. Okay. The Spark, you know, we got some thoughts about what it is. Now, actually, Spark is one of those technologies that you can play with without having 14 computers, right? It's not like Hadoop, okay? You can download the whole tar zip and unzip it and like start up Spark shell, okay? Load up a CSV, do word count, and be like, I know Spark, right? Or you could connect to S3 from your single instance Spark and do some processing in memory. So it's a pretty easy technology to play with, but then you want to do more with it. You may need more juice. Well, there you go. Then you need to decide, okay, am I going to use Spark with Yarn? Am I going to use Spark with standalone? Right? Am I going to use Spark with Mesos? Like, that's when it gets complicated, right? Well, maybe you do want to play with Spark on Mesos to see what it's about, okay? And you don't know anything about Mesos. Well, with Docker, there's actually compositions where somebody's done the work. Spark on Mesos, just Google it. Or you'll land up on some GitHub project where you can say Spark, run sorry, you can say Docker, run this, run this, run this, run this, and all of a sudden you have a 10-node Mesos cluster running Spark, right, on one computer. And that's amazing to be able to play with the same technology that LinkedIn is using to do billions of data point processing in a second. You can play with that technology in about minutes. So Spark has its benefits. It's used sometimes in bad ways. Like some people use it as an integration framework. I don't think it is an integration framework. It's a data processing framework that can be used for moving information to one place, computing it, transforming it, and then sending it somewhere else. But as a pure data computing framework, I think it's amazing. Right? You can do R, Python, Scala, Java. There's even something called, I think it's called Mobius, which you can do C#. So Spark is amazing. It can. I think it is a better version. It is a much better version of MapReduce. It's not separate from. It is separate from Hadoop. It can work with Hadoop, but it doesn't replace Hadoop per se. Okay. But the thing with Spark is it may be easy to get started with, but it becomes harder to scale. Just like Kafka, if you want to do complex, tons and tons of processing, you need to build a cluster, a Spark cluster. Okay. So what technology can help us? Can you do that? Docker could help us here. Yeah, Docker? Yeah, go ahead.
Are there many customers using Docker? And when I say at scale, I mean like processing like terabytes.
Terabytes, you know what? For Spark, no. They actually would run it on either on like the commercial version of Cassandra. DSC has its own kind of built-in Spark, and then other folks, they run it on Hadoop, like Hortonworks. And that's because of, not because it's not technically feasible. For production, they want a commercial company to support that. Ultimately, that's what's holding them back. But do they use it for developing and prototyping? Yeah, absolutely. Right? They want to make sure that their code can parallelize over 10 nodes, do simultaneous reads and writes off of a distributed data system. You know, they want to prototype it. They don't want to have to build a physical cluster. So they'll use Docker to get started there. Yep. Yeah, I mean, when we get to the Docker section, we'll talk a little bit more about how I've seen it in production. Yeah, I think more people are open to seeing Docker basically on your local development and maybe like DevInt or integration testing. Beyond that, getting to staging and production, it's a little tough. Like as I said, I've only worked with 2 clients that use it, but they're smaller, they're software as a service companies, they've got money from institutional investors who are like, find ways to make this better. We don't want server huggers in your team. Like that comes from the top, but that's not a type of culture that most companies are operating right now. Okay. So my favorite database is Cassandra, and I've worked with a lot of different database technologies. SQL Server, MySQL, Postgres, Oracle, you name, these are kind of the big ones that most people use. I like Cassandra because like Spark, you don't need to build up a cluster to start using it. Download the zip file, run Java, and it runs on Java. So just as long as you have Java, it'll work. And adding nodes to scale it isn't that hard. But then if you want to do a multi-data center or multi-region setup to play with it, then you need to build your own virtual machines, and that gets complicated. Beauty of Cassandra is that it gives you today, not the original versions of Cassandra, today it gives you the same or similar language to SQL for your data definition, your data modification language. Right? It looks like SQL. It isn't, because you have to design your partitions properly, or there will be data skew, the same type of problems you have, if you do bad HDFS design or for just sharding your information. But Cassandra allows you to bring some thoughts of tables, and there's materialized views. There are user-defined functions, and there's user-defined aggregates. Again, it's not going to replace SQL, but it gives people a familiar toolkit to create data structures. And it scales, okay? So Sony's PlayStation system that all of the gamers use, there's a video about it where there's two guys that built a production-grade system on Cassandra on virtual machines well before the launch of Sony's PS4, because they were trying to figure out what database, and they're like, well, this one looks like the easiest to maintain. And there's Netflix uses Cassandra, for example. Apple uses Cassandra. I mean, you name a company and they were using Cassandra in some way or form. Golden Arches, company that has golden arches. I don't know what it is, but they use Cassandra. They're using it for, you know, mobile ordering, promotions, things like that. Millions and millions of users. So the type of tests that one has to do when you have to support like a business critical function, like that application makes them money, right? And the type of things they have to do is they have complex architecture about their core middleware. Behind the middleware, there's the ERP system, the marketing engines. Everything has to kind of be up and running. So to simulate a system that can work for 50 million users, right? They need to bring up a complex Cassandra cluster. They need to be able to do not as many as 15 terabytes a day, but let's say 100 gigabytes or a terabyte a day of data processing. So to play with that, again, do you really want to build a cluster, or do you just want to start off small? So Cassandra, great technology, can scale, is distributed, but sometimes it gets a little complicated to make it scale on your own computer. So what are the things that are in common of these three technologies, Kafka, Spark, and Cassandra? It's like a common thread you're seeing. Distributed, okay? So you can, except for Kafka, you can kind of start it in one computer and scale. You can do it on one computer, but it's no good. I mean, you're just, right? It's good enough, but it's no good. What's another thing? They're all built on the JVM. Okay, Kafka is written on Scala, but it's compiled into Java by code. Spark is actually written in Scala as well. That's my favorite programming language now. And Cassandra is Java. It's based on Java. It is Java, and it's compiled into the JVM. The only outlier that I'm going to talk about today is Docker. Docker is not built on Java. It's built on Go, exactly. All right. But it gives you really cool features, and it allows you to play with any programming language you want. So if you didn't want to do Cassandra, and you wanted to use Ryak, or you wanted to use, let's see, Hive, like if you really wanted to use Hadoop, you wanted to have your own Hadoop cluster, you could bring up your own Hadoop cluster on Docker. But Docker is written on Go, and what Docker gives, this is kind of this is right before we get to like what is possible with Docker, right? What is Docker? We talked a little bit about it's a container technology. The best thing about Docker, I would say, is it delivers on the promise that Java started off with. Remember that promise? Write once, run everywhere. That's what Docker delivers on. And even .NET tried to solve that problem. They finally got there just like 2 years ago. Pardon me? What was that? Oh yeah, absolutely. Docker runs on Windows initially using a virtual machine, but now it actually has a Windows core kernel. So you can have a Windows 2010 Pro, or sorry, Windows 10 Pro or Windows 2016 R1. And when you say from Windows Core or Nano Server, and you say, you know, install IIS, that container is only running IIS, or that container is only running SQL Server. And it works. The bindings are exactly the same. And at least on Azure, using the Azure command line interface, you can create containers with either version, Windows or Linux, and it'll run. Right. Yeah. So the question would be why, but .NET Core runs on Linux. It's because ASP.NET 4.5 basically is web forms technology, needs the full Windows version of .NET, and for that you need to have Windows. But if you don't have it, you can port your legacy applications that run on Windows into Docker if you really wanted to. That takes time and money, but I think there's a good benefit you get from that. So quick list of features of Docker, which only will make sense when I show you the next couple of slides. But if you have Ubuntu as a container, you could derive from that. You can inherit from that container and add your own dependencies, okay? Or if you derive from Windows, you could say from Windows, and now my image is called Raoul's Windows. Okay, it has a few more things that I wanted on it. And then, or let's say at my company, we can have an Anant Windows or an Anant Linux. And then all the team members would use from Anant Linux and apply what they need to do. And anytime there's an update to Ubuntu or to Windows, if I rebuild my container, it will cascade down so that my image is up to date from the core. Okay, it's just like an object. You inherit from it, you use it, and every instance of it, right, every time your container runs, it's using that same image. And these images are immutable. And you can publish these images in a private registry, or you can publish these in a public registry. So dockerhub.com or hub.docker.com is a public registry of all the public containers that are out there, public images that are out there. And there's probably an image for basically everything. And if it's not published on there, somebody's written something and put it on GitHub. Okay. Everybody, yeah, go ahead. It could, but if you tag your image properly, it would always derive from that particular version of the core, right? So it doesn't have to break your film. That's the cool thing about it, is that if I'm using Ubuntu 14.4, all right, and then 16 something comes out, I don't have to use it until I test it. And after it's tested, all I'm really doing is changing one line of code in my Docker file to say, now use the latest, you know, all right? So a company called Instacluster, they do manage Cassandra. They have a great talk on Docker where they showed how the versions of Cassandra that are out there and the different type of clouds they work with. So Rackspace, sorry, Amazon, Google, Azure, I think, but just three versions of Cassandra and 3 clouds, they would have to maintain 9 different images for their software, for their managed services. But with the Docker, they have to have only 1, or maybe 2 at times. So what I really wanted to say is industry-wide adoption, like everybody that is starting to use Docker, there's no common thread. There's people in marketing, people in software, people in managed services. They're all starting to use it because at the very least, it allows people to just test software much quicker, okay? I've tested it with .NET Core on Linux, and I've tested it with legacy.NET SQL Server on Windows. And you know, today I do things with what's called Alpine Linux, which is a smaller version of Linux specifically made for Docker. So the images aren't like 400 megs. Like an Ubuntu Docker is 400 to 500 megs. An Alpine Linux, it's like with some NPM installs, with the NPM install, it's like 60 megs. Okay. So any questions before I go into the applications of Docker? Any thoughts? All right. So Trend Micro uses Docker to basically process logs. But I would argue that this architecture could be used for any type of processing of information. Okay, they get logs from all of the machines in their. This is not your computer that runs Trend Micro, but like all of their servers, they stream logs into Kafka. And I'm not talking about Akka because that's a complicated subject. that's a different talk. But they use Akka to basically respond to the events and save data to Cassandra using an actor model. And then they use Spark to read from the stream and use historical information to come up with insights. Yeah, go ahead. What is Akka? So an actor-based model, it's a type of object that literally has like receive and send as methods and like process. And it comes into being, it does its job and goes away. And Akka is written in Scala and can work on Java. But you know, the actor model has been around for a while. It's also in Erlang. So for real-time processing, it's perfect because it comes in, has no state. It comes in, takes a message, does something with it, goes away. So for stream processing, if all you're doing is reading from the queue, saving it to a database, you don't need any special infrastructure to do that. Right? So the Akka is good for that. But again, you can go deep into the actor model and how it's useful. It's also another distributed real-time framework, different from Spark in that it doesn't focus on in-memory because like stuff comes and goes. But Spark, up until like the last version, used Akka internally to do stuff. So again, that's a different subject altogether. But Spark here is being used to basically take information and let's say put it into a relational database. Okay, so here's the complex application. Okay, we've got web portal servers, we've got API servers, we have a database server, right? We've got Spark servers, Cassandra, blah, blah, blah. So to test it, if we didn't use Docker, we would have to have at least 4 computers here, maybe just 1 or 2 here. That's 6. And you got to have at least 6 servers for Cassandra properly. All right, so we got 12, another 6 for Spark, so that's like 18, 19, 20, 21, and then just to have a Fluentd server, let's say well, Fluentd kind of streams it from the different sources. So let's say on a roughly 20 servers. So just with virtual machines, if you were doing it locally with VirtualBox, come on, are you really going to maintain that many images? And how are you going to maintain that in source code? Ansible, Chef, like to prepare a Kafka server? Like forget it. I mean, I like Ansible. I think Ansible still is useful. But with Docker, what you can do is you can write your code for all of these different things and define your container as one file. Every one of these things can be defined as one Docker image. And the code to write that image is one file. That's the simplicity which, well, there are conditions that you can put in there with other stuff like Ansible, but because it's immutable, you can throw away the whole environment and make changes and then rerun it, and it'll be completely fresh. Okay, so its beauty comes in the fact that it's immutable. Its beauty comes in the fact that it's simple, and its beauty comes in the fact that it's composable as an architecture, and this is called a compose file, where each of these little sections in the YAML is basically saying, I want to run this container with these command line parameters. If you didn't have the compose file and you had 20 different components, you would run Docker run 20 times. But with Docker compose, you just have one file called compose, and it will then basically run everything for you. There's a lot of controversy around orchestration. So Docker compose is what you get with Docker. And the same YAML format allows you to run on something called Docker Swarm that's built by the people that make Docker. They're the people who got an evaluation of what, $1.5 billion recently? 1.6. 1.6. That extra $100 million. Not insignificant. Yeah, $1.6 billion, exactly. They have their composition format, but Google has a competing format, Kubernetes. All right. There's another format called DCOS. Okay. Docker Container Orchestration System, and it's slightly different. And I'm a big fan of Cloud 66. It's a CI platform. Yeah. Mesos. Yep. So, well, Mesosphere. Yeah, you have choices. So my recommendation is, if you want to play with this on your computer, learn Docker Compose, because there's nothing that's easier to like pick up. Okay. And everybody that's developing the software locally uses Docker Compose. You're probably not going to run Kubernetes on the first day. When I say probably not, like unless you're using Kubernetes, you're probably not going to use it. And I have some real world examples out there on GitHub that I'll point you to in a second. But in this, if you just take a look at it, this is a voting app, and it's saying use this image. So there's some like conventions around image naming. So this is your username, the name of the image, and then the tag. You can have like latest or some version. So whenever you tag your image, whenever you build it, you can say, this is what I'm naming it. Ports, this is the internal port. I want to expose it on port 80. I want to put it in this network, so you can define networks. This particular image depends on this other image down here. I think it may be up here called Redis. And then this is the tooling around Swarm, which is I want 2 replicas of this particular image, or I want 5 replicas of it. Or if you want to run multi-instance software, okay? My open source project that I work on, where I learn all this cool stuff, is called Appleseed, and I'm working towards this architecture where there's a couple of different data ingesters built on whatever framework, but it runs on Docker. Standardizes data into CSV or JSON, puts it into a queue running on Cassandra, and then it processes that data using Spark and eventually exposes that data into other Cassandra databases. And then once it's a data product, which there's a SQL Server, let's say, potential data product, or there's a search index from Solr that's a data product, to serve that up, thinking about using GraphQL. So to play with this framework locally, I need something like Docker. My machine has only 16 gigs of RAM, okay? And I can't run, it's a Mac. I can't put more memory on it. Okay, so for me, Docker is useful for not only on working on client stuff, just working on frameworks that I'm trying to iterate. It's very useful. Okay? So there will be a mixture of Windows and Linux containers in this framework, and I'll show you what that look like. The whole thing isn't complete, but this is what I'm going towards. It helps me do this, but I'll end in about 5 minutes. What I wanted to show you was what Docker files look like. So this particular repository basically, and I can show you the Docker Compose file so you can see, brings up an Apache container and brings up a .NET container running .NET Core, brings up a Mono container running Mono, has an Nginx proxy to then give me the front end for all of these things that are happening in the back, right? I've got to have some way to give a facade to all of these little microservices in the back. So Nginx is one of the good, very commonly used proxies. There's another one called Traffic. It's a little bit simpler to configure than Nginx, but one of my colleagues uses that. I've got my Solr, my Elastic. I find my container to basically store data, because everything is immutable. You know, I'm essentially throwing away everything every time I restart it. So I create a container called storage, and I save that on. I mount a local host volume, And I've got some other stuff I got to add to it, like MySQL, PostgreSQL, Redis, so on and so forth. But this is just a composition file. So when I say docker compose run, it then goes into one of these directories and it builds that Docker and then it runs it. So let's just take a look at a Windows Docker file. So I didn't make this container, right? All I'm saying is get it, Mongo, running on Windows Core. And why did I inherit it? Even though it's already published. So that if I needed to go and add stuff to it later, I could do it. But I can have one kind of pipeline, right? Let's see. We've got .NET from Microsoft, .NET Core. Copy my app code into the app directory, make this my working directory, run .NET restore, which is like npm install, expose this port. Oh, sure. Then it says .NET run. So this is Dockerfile language. It's like bash scripting. And you can extend it with PowerShell or with bash scripting. But this basically runs my code, okay? To give you another example, I've got an Angular app, and you know, it just better show it. You know, I didn't make this image, right? Get the latest node container that somebody else has published, make this my working directory, copy all my files, run npm install and bower, expose on port 90 up 9000. And then run node. Okay. So this, if I pull it down, I can just say git clone this repository, go into this directory, docker build, docker run, and it will work exactly the same on your computer as it will work on my computer. Or if I go to a Azure virtual machine with the Docker plugin installed, git clone, docker build, Docker run, it will work exactly the same, right? Or now with Azure Container Service, I can say create my container, and I can say publish, build this code, publish it on this tag, and I can say run this container, it will run exactly the same. So truly, I have here write once, run everywhere. And if I use things like composition, then I have built my whole stack. The server, the network, the web server, the API server, the database server, everything. The load balancer, right? I built the whole thing as code, and I didn't have to learn Terraform. I didn't have to learn Ansible, although I can. I like Ansible. But this is not rocket science. I've just shown you two formats, a Dockerfile format and a Docker Compose format. All the things we've been talking about are available by just learning two ways of thinking. And I have a knowledge base I've been building, and I actually did this as part of a class. I taught a class in my office, but basically this is a knowledge base that runs as a Docker container. So, you know, this is recorded, but if you go to this, you clone it, and you run it using your data, it'll run the knowledge base. But I wanted to show you one thing before the Q&A, and I think after that we'll probably have to wrap up here. But I want to show you so there's two toolboxes that I found, one for big data and one for data science. And let's just take a look at Dockerized Spark Cluster Deployer, or maybe Hadoop, Spark, and Docker and messes. And this talk basically shows how somebody built a full Hadoop cluster on Docker, and actually the code is available. It's somewhere in there, but it walks you through the process of building. And I wouldn't actually go through and like look at this presentation. I would just say, where's the GitHub repo? Pull it down and build it. Okay. Here's another one. Actually, I think the data science one is here we go. Yeah, Docker DriSupport. So they have a Docker Compose file, right? They've got a master. They've got a slave. That's it. All of a sudden. And if you wanted to have more, you could have replicas for this. Okay. And let's see. Yeah, and they have Swarm as well. So I'm gonna stop right there and open it up for questions. How much time do we have for questions, by the way? Okay, perfect. So anyone have questions about what we covered? And we can dig deeper into either Compose or Docker, or look at some examples, or just chat about, you know, how it could be useful in your company. Okay. Sure, that's a really good question. So the question was, can I use Docker Compose to create different compositions in different files? And the answer is not Docker Compose, but using Docker, what's that? Or what's called Docker Machine. So you can do it locally. Okay, this is the way I would do it, right? I would make 3, let's say I wanted to test out Azure, Google, and Amazon. So I would make 3 Docker machines locally, okay, for first, before going to Swarm. Make 3 virtual machines locally using Docker Machine, which is another tool, and using the VirtualBox driver, okay? And I would say, hey, Docker, connect to machine A, run this Docker Compose, connect to machine B, run this Docker Compose, and connect to machine C and run this Docker Compose, okay? And I would have simulated a multi-cloud environment on one computer using 3 virtual machines. Then I would shut down my Docker machines, and I would say, Docker machine, make a machine on AWS. Docker machine, make a machine on Azure. Docker machine, make a machine on Google Cloud, and do the same thing. And at that point, I'll have 3 virtual machines scattered around the world running Docker Compose, okay? What does Docker Swarm do? Docker Swarm allows me to talk to a swarm of servers as if it were one machine. That's what Swarm gives me. So you still need to do Docker Machine on 3 different clouds before you can do Docker Swarm on 3 different clouds. That's up to debate. That's just an entirely like opinion thing. People will give you, yeah, I think he has some idea. Yep. Mm. It's a cool looking suit though. Yeah, so like if I were to make a multi-cloud system, right, that would be the approach I would take. is use what I just explained to you, but Google Compute is built on Kubernetes. Azure is built on DCOS, but you can run Kubernetes on top of it. And I think AWS uses Fleet or something like that. But at the end of the day, like, use what people are using rather than what seems cool, because ultimately you don't want to get in the business of managing your own stuff. So that's the most politically correct answer I can give. Other questions? Yeah. Sure. Yeah. So challenge number one was the best way to like deal with challenges with new technology is to teach classes along. So, because then you have 5, 6 people trying to figure out how to do something. So making sure everybody had the right version, the dev team had the right version of it. Like, that's hard. They'll download Toolbox when they really don't want them to use Toolbox, or coming up with a standard of like, how do you go from local dev to the next level up, all right? And the best way to do that is having kind of best practices in Dockerfile, best practices in Docker Compose, best practice in repo design. So, you know, my, what's that? Tagging? Yeah. It's the same stuff that you just like, how to use GitHub properly. So I learned a lot from Docker best practices on docs.docker.com. Also looking at how other people made their boilerplate Dockers. Like this one, CCAN Docker, I think it's like Common Knowledge Something Network. They have one of the most like comprehensive Docker Compose, where they run a lot of these different software. I'm like, wow, that's kind of what I want to do here, right? So I learned a few things from other people, but I mean, like this idea of having a folder for Docker and then having a different folder for each of my Docker files, I didn't come up with that on my own. I just saw several people doing it, and I was like, that's the way it should be done. Now that we're dealing with multiple product solutions, so, you know, I have to separate the Dockerization for the build and test from the Dockerization for running it, from the Dockerization of composing it for a client. And that's all like meta DevOps. It has nothing to do with Docker. It's how do you manage your process for these different things. And because you saw the format is simple. I've seen some complex Docker files, but that's just because they don't want to depend on anybody else. They want to have everything that they picked out for their build. What to do? Like, I just used Node latest and it has everything I needed. If I wanted a lightweight version, I would say Node Alpine, and it would give me the lightweight version of Node, right? The people that make WordPress have published a WordPress Docker on Ubuntu, but also one on Alpine. So anything that I can use from the outside world, I'm using. That's my kind of thought process. But maybe you're in an environment where you can't use everything from the outside world. You have to start from scratch. The Ubuntu container starts from scratch. Like it says from scratch. That's the parent. That's like object in JavaScript or Java, right? So yeah, you could do that. Not sure you want to. It's like, I want to make an operating system. So this is as close as you can get without wasting too much. So another cool thing is that Docker exposes its API via REST. So when you say Docker run, the Docker service has exposed a REST API. So we started to use different tools. I didn't make it, but there's tools out there that will monitor Docker hosts, memory usage. They will collect the logs or the standard output from all of the Docker hosts. But then at some point you're like, forget it. Let's just use what other people are offering. So AWS, Google Cloud, you know, Cloud 66, they have all these ways to give me what I wanted without having to have my own memory management and logging frameworks. So best thing I can tell you is use something that somebody else has done rather than try to reinvent the wheel. Yeah. Mm-hmm. Unless you log everything. That's a really good point. Yeah. Yeah. Mm-hmm. Yeah. Yeah, or you use an alerting engine, right? Like you can use New Relic, and that's what we use for a lot of stuff. We just put stuff in a New Relic and tells us when something dies. Yeah, go ahead. Yeah, because it is the same thing that's running on the cloud. Yeah, if it's breaking globally, it's going to break locally too. Right. Yeah. There's also some things you have to know about each of the different clouds. So like in Azure, you can't have you have to have a long running Docker. Like if your Docker is supposed to just come and go, and I have a bunch of those in data operations, run this, run this, run this, run this, and then come back later after an hour, you can't do that on Azure. So you have to build it into your container to say, hang out for 10 minutes and then come back. Or you have to do some kind of orchestration outside. So all of the different companies have something that's theirs. I think that DigitalOcean actually does a pretty good job of explaining how to use Docker. I learned a lot about Docker, like reading their documentation, but I would never use DigitalOcean to like run my stuff. I don't know why. It seemed like an amateur house, but do you guys know why Docker was created? It was to create something that was going to compete with Heroku, but to run stuff that was not Ruby on Rails. But now, like, you can do everything else on Heroku as well. That's why they created it. The company that started Docker created this to basically be like Heroku for everything else. And ironically, now you can run Docker on Heroku. So the world has come full circle. I have a great deal of fun talking about this subject, and I've done a couple of classes. But if you guys ever want to just talk about this stuff, I have a semi-private Slack group where there's a channel just on Docker, and we just shoot the shit and talk about stuff. So just come up to me after, and I'll invite you. I also run a Data Wranglers meetup group, which I think in the next 3 months we'll have a Docker for Data Ops coming up. So I'll ask Joanna to kind of cross promote that meetup whenever that's going to come up. But I've had just a phenomenal time just being here and talking about it. You guys were very receptive and kind of open to the technology. Yeah, do you have a comment there? Yeah, so Heroku is a platform as a service in that if you don't want to have to worry about scaling Postgres, so this is before like, Elastic Beanstalk or Azure. It's kind of like Elastic Beanstalk. It runs on Heroku's versions of containers called dynos. It runs on AWS. And it's now owned by Salesforce. Yeah, and actually, one pro tip about Heroku is that if you want to do any Salesforce integration, you buy the Heroku Connect product, which synchronizes Salesforce data into Heroku Postgres, and you can write any code to talk to that Postgres database. So in my eyes, that's kind of the only value that Heroku has, is Postgres access to Salesforce data. All right, cool. All right, thank you so much. Joanna, did you have any parting words?